Okay, so let's move on to this one. This is concept application, and we're now on page 115. And we're going to start with the very first problem, and it reads, Everett is reading a book for his language arts class. He read 1/4 of the book on Saturday, 3/8 of the book on Sunday, and 1/4 of the book on Monday. So 1/4, 3/8, and 1/4. Which procedure can Everett use to find the total fraction of the book he has read? So underline our question. We circled our keyword, our numbers, and now we're going to box in a key term, total. So total means we're going to add. So before I even look at A, B, C, and D at the bottom, I'm going to find my own little process. So I know that I have 1/4, 3/8, and 1/4. Are they all like denominators? No, they aren't. So I have to set them up into what? To eighths. And then I'm going to have to add. So let's see if we can find one of those that makes sense with this. You're going to write equivalent fractions using a common denominator, which is true so far, but then it says, then subtract the sum. No, we're not subtracting, we're finding the total, so A cannot be it. Since this was almost it, let's check D. Write equivalent fractions using a common denominator. Yes, because you're going to bring these all over and turn these into eighths. Well, that's already eighths. This is times 2 again, times 2. Okay, so then what are you going to end up with this? Then find the sum. Then you would add the sum of the fractions. That's right. Okay, it has to be this one. You're not going to find the sum of 2 of them and then subtract it. Absolutely not. Okay. Moving on to the next one, and it says Hannah grew a total of 1.5 inches this year, as shown by this. Okay, 1.5. Great. Hannah grew 7/8 of an inch last year. Which equation shows how many more inches Hannah grew than last year? So we have 1.5 and then 7/8. Look at the question. How many more than? What does how many more than tell us to do? It tells us to subtract to find the difference. So we're going to go ahead and write 1.5 and subtract 7/8. And the 7/8 stays in the fraction column. So then we're going to, can you count by 2s and land on 8? You can. So we're going to let both of these be eighths when we finish. So this is already 7/8, so I just brought it over. 2 times 4 is 8. 1 times 4 is 4. Okay. When we're subtracting, we've learned 4 minus 7 I cannot do. So I'm going to go next door and rename this one to just 8/8. 8/8. And when 8/8 goes back over to fraction, they go together as a team. So that makes 12/8. 12/8 minus 7/8 is my new problem. 12/8 minus 7/8 is 5/8. So now which one of these is it? There it is. You must always prove your answers. Prove your answers. Prove your answers. I hope that didn't move so much. All right, let's go. This next one, Luke buys 8,500 kilogram of bananas and 7/10 kilogram of apples. Okay. Which is the best estimate of the total number of kilograms of apples and bananas? So the best estimate. So we're going to look at 85/100. 85/100 is only 15/100 from being away 100/100. So we're going to say that this one estimated is about 1 whole. And 7/10. Okay, so think of it like this. Is 7/10 closer to a 0, 1/2, or 1 whole? Well, exactly 1/2 would be 5/10. Well, 5/10, 7/10 is only 2/10 away from being in the halfway mark. But to get up to a whole, it would have to add 3 to the 7 to make it 10/10. So that's more of a move to get up to 1 whole. So we're going to say that 7/10 is closer to 1/2. So these are our estimated. So 1 plus 1/2 is 1 1/2, which is in between 1 and 2. You may want to go back and watch that again. Now, we're going to look at this next problem, which is dealing with the bananas and the apples. And let me make sure it's all up here in good focus. Luke wants to know how many total kilograms of bananas and apples he buys. He uses these models. Each large square represents 1 whole. So if everything was shaded in, this would be like 1 pizza, but it's not. If everything was on this, it would be like breadsticks, or a pizza where you're taking long strips of breadsticks. Now, what I want to do is I want to come up with, what is this name for this drawing of bananas? Well, we know this is a 100s board, and so we know that bananas is worth 85 100ths. Apples, there's 10 strips. How many are shaded? All but 3. So that's 7/10. So what we're going to want to do more than likely is we're going to want to give 7/10 a new name. We could rename this to 100ths. So what did I do to the 10 to get 100? 10 times 10 and 7 times 10 is 70. So now we have 85 100ths plus 70 100ths. And let's see if we have anything close to that. Well, that's not 7 out of 100 because that is so much more than just 7 bite-sized pieces. All right, now let's look at this one. Does this one look like this is our new name? Sure enough. So we know it's going to be B. And our last problem, it just says how many kilograms of bananas and apples does Luke buy? So we're going to go ahead and go back to our former problem. So one problem builds upon the first one. And I'm just going to go ahead and stack these. Even though we've got the like denominators, that's fine. So now what we're going to do is we're going to go ahead. 5 plus 0 is 5. 5 plus 7 is 15. So we have 155 over 100. What is this? Improper. So we can divide 100 into 155, and it will go how many times? 1. What did I just do? I drop the numerator. Top dog gets a house. Numerator gets a house is important. Here's your divisor. It will go 1 time. And we're doing this in our head, but if you have to do it out, that's okay. Since we have a fraction, this becomes 55 over what? 100. All right, so that's 1 and 55 100ths. Now let's see if we have that. If not, they may have simply simplified the 55. So let's see. 1 and 55. Oh, okay, yay, they helped us out on that one. Okay, very good.